Hello and welcome to Math200 Statistics Online here at Cañada College. My name is Lapuz. In this video, we will take a look at a homework problem from section 3.4, number 1. Here it says, according to Master Foods, the company that manufactures M&Ms, 12% of their peanut M&Ms are brown, 15% are yellow, 12% are red, 23% are blue, 23% are orange, and 15% are green. They want us to round our answers to 4 decimal places when possible. And for the first one, they want us to compute the probability that a randomly selected peanut M&M is not yellow. So let's take a look at the percentage that is yellow. And if we look at the percentage that is yellow, it says 15% are yellow. So they want not yellow, so we want the complement of that. So that's 100% minus 15% is equal to 85%. And they want us to write our answers as a numeral instead of a percentage, so we're going to write it as 0.085. Okay, the next one. Compute the probability that a randomly selected peanut M&M is yellow or red. So this is an or. Maybe we should write our P notation, yellow or red. And the probability that it's yellow, again, is 15%. This is an or statement, so this is going to be 15%. And plus, the probability that it's red is 12%. And this is going to be 27%. By the way, this is an or statement, so we're going to use the addition rule, but these will not, these are mutually exclusive, so we don't need to worry about subtracting anything out. So we got our answer 0.27, and we're off to the next one. Compute the probability that if we select 3 randomly selected peanut M&Ms, they are all orange. And so it looks like we're going to assume, since these are huge probabilities, or these are probabilities for the whole population, the total amount of M&Ms that they produce, and we're not necessarily just picking it from a bag, we're picking it out from the factory. We can assume that we're doing these 3 experiments without, with replacement. Let's put it that way. We're doing this with replacement. So the probability that we get an orange in our first pick times the orange in the second pick times probability of getting orange in a third pick is just going to be a multiplication rule. And since we're doing this with replacement, we're assuming we're doing this with replacement, then it's just a matter of computing the amount or the probability that we get an orange. So this is 0.23, and then we're not counting anything out. The probability for getting another orange is going to be the same, and then the third orange is going to be the same. So we will just put this in our calculator. That would be 0.23. Oops, let's put a point here. 0.23 times 0.23 times 0.23, and we're going to get 0.012167. So 0.12167. We want to round to 4 decimal places, so 1, 2, 3, 4, but the fifth digit is a 6, so I'll round this 1 up to 2, so that's 0.0122. 0.0122. Now, if we have any issues, we can certainly put in the whole thing up to 6 decimal places. At least that's how my calculator figured it out. So we could have put up to 6 decimal places here if we wanted. But they said round up to at least 4 decimal places, so that's 4 decimal places. Okay, off to the next one. If you randomly select 3 peanut M&Ms, compute the probability that none of them are green. So what we're going to assume that we're going to pick one and assume it's, or find the probability that it's not green. Pick another one, find the probability that it's not green again, and then pick a third one, find the probability that it's not green. So I guess we're going to be concerned about what the probability is of not green. And so green, if you remember, selecting a green M&M, well, we haven't done it yet, but it's going to be 15%. So it's going to be 0.15 of selecting a green, but we want not green, so it's going to be anything else but the green, which is going to be 100% minus 15.5. That's 0.85. And then we're going to want this to happen 3 times, because in none of the picks do we want a green M&M. So we're going to say probability of not green times the probability of not green again, and then times the probability of not green for a third time. And those are your 3 M&Ms. None of them are green. And so this is going to be 0.85 basically to the third power. So if you prefer to use less strokes in your calculator and your calculator can handle scientific notation, this is just 0.85 to the third. We have our standard calculator here, but if we get it into, well, let's just leave it like this and go 0.85 times 0.85 times 0.85, and we're going to get 0.61412, 61425, 0.61425. Again, rounding off to 2 decimal places or 4 decimal places. I look at this 2, that's less than 5, so I'm going to stick with 6141, 0.6141. Now finally, you randomly select 3 peanut M&Ms, compute the probability that at least one of them is green. So at least one of them is green, and you could have 1 green or 2 green or 3 greens, but regardless of how you put it, it's going to be the complement of the previous one, of none of them are green. So so that's it. At least one green. Find the probability at least one green. It's just going to be equal to 1 minus not green, not green, not green, all of them together. So it's basically 1 minus the previous answer that we got. So 0.614125. You can put this in your calculator, or I can just take this and subtract 1 in our calculator, minus 1. I know I'm going to get a negative number, but you switch to positive and negative, or you can just literally just do this computation. So that's 385,875. By the way, I know it says negative up there, but we can just not worry too much about that. Okay, this is our result, rounding out to 4 digits, 1, 2, 3, 4. We look at this, this is a 7, bigger than 5. So I'm going to add 1 to 8, so 3859, 0.3859. Okay, so that's a little help from your homework, and I hope that helps. Good luck.